Today, we're starting Unit 3. We are talking about factoring. We're going to talk about GCF, difference of two squares, and trinomials. Good morning. So remember that when you're factoring, Chris, the first thing you always want to do is check for a what?
Ordered pair.
Greatest common factor. Okay? So in this case, if you're looking at this problem right here, do you see a GCF?
3.
3. Because you're always looking for, is there a number or letter that will divide evenly into everything that is in your equation, okay? All right, so 3 can factor out. So I'm going to write a 3 and a parenthesis, and then you're dividing each of these terms by 3. Okay, so here the 3's cancel out, and I'm left with an A minus, and 3 goes into 36 how many times? 12. Always double check to see if you missed something, but there's nothing that can factor out of A and 12. And we can't factor this further. Okay, so this is my answer. So far, so good. All right, example 2. So again, we always check for a GCF first. There's no GCF. Would you guys agree? Because this only has x's, this doesn't have any x's. All right, so when you have two terms, if they are not a GCF, then you want to check to see, is this a difference of squares?
Yes.
Well, a key thing is difference. If this was a plus here, it would not be difference of squares, right? So you need to have a difference, a subtraction sign. And then you need to check, are both of the terms squares? So x is a square, but can I write 121 as a square?
Yes.
What is 121 as a square? 11 squared. So I like to write both of them as squares. And then when you factor difference of squares, basically the way I think about it is you're like pulling apart the squares. So x squared, we separate them. See how x is in the front? I'm going to put an x in the front of both of those. Same thing with the 11s. The 11's at the back, but I'm going to split them apart. So I'm going to put 11 in the back of both of those parentheses. And then when you have difference of squares, one is going to get a minus sign and one is going to get a positive sign. And that is how you factor a difference of squares. If we were to multiply this back out, which we're going to do later on, you would end up getting back to this original problem. Okay? And the reason why one is minus and one is plus is because if you multiply a negative times a negative, what does it end up making? A positive.
Now, question: when you were like putting it back to what it was originally, don't you just like
Foil?
Yeah.
Yes. You can do foil, or we'll kind of talk about, we call it box method, but we'll talk about that in a little bit. All right. Any other questions right now on example 2? Okay. Example 3. So again, what is the first thing I always want to check for?
GCF.
Good. So if we look through here,
A.
A is a GCF. Good. I also notice this has an x squared, this has an x, but does this have an x?
No.
No. So can I take out an x?
No.
No. All of them have to have it in common. So I'm going to write an A and then make my parenthesis. And I'm going to go through and reduce each of these by A. Okay, when I do that, the A's cancel and I get x squared. Here the A's cancel and I'm left with what? Good, minus 2x.
-15.
And then these A's cancel and we have minus 15. How many of you remember your teachers talking about the diamond method? Okay, so I'm going to talk about the diamond method, but at some point in this class, I'm hoping that you guys will be able to do the diamond method in your head without having to write the diamond method out. Okay, but the diamond method, does anyone know why they called this the diamond method? Very good. If you connect all the lines here like this, it makes a diamond, but most of the time your teachers just probably made the X. But if you guys notice, that looks like a diamond. Okay, on the top, okay, now this is where some teachers do it different ways, but I think most of the teachers made this as the number at the end, which is your multiplication number. I'm going to do it. You can do whatever you want to. And no, it's okay. And -2 down here, this is your adding / subtracting number. Okay? But in here, what I mean by moving away from it is we just need to remember that our middle number is like our adding number, and our end number is our multiplication number. Okay? So I might not make these very often. If you want to make these, you can. Okay? But I just always mark these. Do you mind getting it for me? So, what numbers multiply to be 15? I want to list all the numbers.
She said she'll call you later.
Okay, perfect. You're good. So what numbers multiply to be 15? Okay, let's write these out. 1 and 15. I always try to go in order so that I don't miss anything. So 1 and 15 multiply to be 15. Can 2 and anything make 15? No. No, 2 and 15 can't. Can 3 and 15 multiply?
Yes.
Wait, it's not 3 and 15. What is it? And what else? Okay, because the next number would be 5, right? 5 and 3 we already wrote. Okay, so looking at these numbers, 1 and 15 and 3 and 5, which ones could I make to equal 2, to add or subtract to be 2? 3 and 5. So 3 and 5 are my numbers, but we need it to be a negative 2, so that means 5 needs to be negative. So if we subtract those, it makes negative 2. If we multiply them, it makes negative 15. So it's kind of like a puzzle. You're always like, you're making sure the numbers work for both multiplying and they work for both adding or subtracting. So now when we write our answer, we make our 2 parentheses just like we did with difference of squares. Since you have x squared in the front, again, we're splitting those x's apart and we're putting x in front of each of these parentheses. And then you have a plus 3 and a minus 5. Always double check if there's anything we could factor further, and in this case there isn't, so this is my answer. Good. Okay, questions on example 3?
Nope, but I know.
Okay, example 4. What do we always check for first?
GFC, and we have one.
Good. What is... Very good. 2 is my GCF. Okay, so we are going to write a 2 and make our parenthesis. Then we go to our original problem and we're dividing by 2. 18 divided by 2 reduces to what? Very good. 9x squared. Then I have a minus sign, and 8 divided by 2 reduces to, very good, 4y squared. Okay, so, and then we check, can this be factored further? I have 2 terms.
Yes.
Good. Yes, you can. And so when we have 2 terms, is this a minus sign?
Yes.
Yes. Now we check, are these squares?
Yes.
Can 9 be written as a square?
That's 3 times 3.
Good. So 9 is actually 3 squared. What can 4 be written as?
2 squared.
2 squared. So I'm like crossing out those numbers and writing them as squares. So is everything in this parenthesis a square now? Yes. So now we're going to do just like we did in example 2, except we still have that 2 in front. I'm going to make my 2 parentheses, and we're going to pull apart our squares. So what's going to go in the front of each of these parentheses?
3 x's.
What is first?
X.
No.
3.
3. I'm writing a 3 first. What is right next to the 3? An x. So you're pulling apart each of those squares. Okay? One of them's going to have a minus, one of them's going to have a plus, and then what will be next?
3x plus 2y.
2y. You're pulling apart the 2's and the y's. Okay? So whatever is squared, you are separating each of them and putting them basically in the same spots in the 2 different parentheses. Are there any questions on example 4? Yes, Marcus. Then you wouldn't be a difference of squares. So in order for it to be a difference of squares, everything has to be a square. It can't be a cube. It has to be a square. Okay? Any other questions? All right, so there's my answer because they cannot be factored any further. All right, moving on. Okay, what do we always check for first? A GCF. Okay, is there a GCF in this problem? No, this has a y, this has a y, this does not have a y, right? This has x, x, this does not have x. All of them have to have it in order to factor something out. So we can't factor anything out. So now this is 3 terms, and whenever you do a trinomial, you're doing your diamond method, okay? So on this diamond method, what number is in front of here? 1. Okay, a negative 1, okay? Remember, this is my adding number. And what number's here?
-6.
Negative 6. And this number is my multiplying number. And if you want to make a diamond, you can, but again, I'm going to not make them. Okay, so I always look at my multiplication number and I write down all of the numbers that multiply to be 6, starting with 1. So 1 times 6 is 6. Is 2 times something 6?
Yes, 2 times 3.
Good. 2 times 3 makes 6, and then the next one would be 3 times 2, and then we just are repeating. Okay? So out of those 2 sets of numbers, which one will make a negative 1? Very good. Okay, so let's make our parentheses. And actually, in order for it to make a negative 1, which one should be negative?
-3.
Okay, so if you want, you can put a negative by the 3. So what am I going to separate in the front of each of my parentheses? Good. A y is correct. Okay, and then we said one of them is going to have a positive 2, and one of them is going to have what? -3. But there's something at the end here.
Yeah.
What am I going to do with that?
Add it.
Good, you're just going to separate it. You're just going to have an x at the end of each of these. Just like how you had the y squared at the front and we separated it, you're going to do the same thing with the x at the end and we separated it. Just like how we had with our difference of squares. Can these be factored any further? No, that's my answer. Questions?
Why would you put the y in
Because the y's in front. That's why. Yeah. Yes.
the x and y in the middle?
So, and I don't know why I don't talk about this sooner, but when you multiply this out, do you remember the FOIL method or the box method? Which way did you do it, Rome? You don't remember? FOIL? So, what happens if you're multiplying this back out? We'll kind of go through this. Y times y makes y squared. Y times negative 3x makes negative 3xy, because we always write in alphabetical order. Okay? 2x times y makes a positive 2xy. And then 2x times negative 3x makes a negative 6x squared. These both have xy, so we would combine our like terms, and we get y squared minus xy minus 6x squared. So notice how these match. So this factored, or this factored to be this, and if you multiply it back out, it goes back to your original problem. So the xy comes from when you're multiplying your outsides and your insides together, give you an xy term. Okay? Any other questions on example 5? Okay, example 6. What do we always check for first?
CFC, we have one. And it's
GCF. Good. Greatest common factor. And what is my greatest common factor on this
eight.
problem?
8.
8 is correct.
8 parentheses x squared times 4.
Good. So I'm going to go through and divide each of these by 8.
And then we have
These cancel, and we get x squared minus, and 32 divided by 8 is 4. Now, there's just 2 terms. Whenever you have 2 terms, you want to check, is it a difference of squares? So, this is already written as a square. Can 4 be written as a square?
yes, minus x squared minus 2.
It's going to be what?
8 parentheses
What is 4 written as a square?
x squared.
2 squared. Thank you. Okay, so we have 8, and then we're making 2 parentheses. You're just going too fast for me right now. And we're going to separate our x squared. So what's going to go in the front of each of the parentheses?
Yes.
X. We're going to separate our 2 squared, which will become what?
Minus 2 plus 2.
Very good. One has a minus and one has a plus. And if you notice, kind of back to what we talked about in example 5, if I were to multiply this out, my 2 outside numbers and my 2 inside numbers. So my outside numbers would multiply to be 2x. My inside numbers would multiply to be negative 2x. And what's 2x minus 2x? 0. So if you go back and notice how there's no plain x term in here. So by having the minus and the plus, it ends up making terms that cancel out, so there actually isn't an x term, just your x squared term. All right, example 7. Okay, I want you guys to try this on your own. The first 3 that get it right are going to get a candy. Don't forget to double check once you factor if you can factor something further. No, you're on the right track though. No. This is kind of a trick question. Maybe. Yes. Start with GCF. You were close. Okay, so at this point, difference of squares. Are either one of these difference of squares? No. Because this is a minus, this is a plus, so they're not the same. Yes, and then what else? So this became this, and can you factor that one? No, right? You can't. So you're just going to rewrite it. Because that one's not a difference, it's a positive, and you can only factor different squares.
You like that song?
Okay, you got it now. Did you finish it yet? You guys finish it. All right. Let me check one more.
Hey, you can do it like that.
Okay, so what do we always check for first? GCF. GCF. Okay, so we're taking out a 4, making our parenthesis. We divide these by 4, and then what am I left with? X to the 4th minus y to the 4th. Good. Okay, I have 2 terms I want to check. Can I write these as squares? How can you write x to the 4th as a square?
X squared, X squared.
Okay, this is really x squared squared, right? And this is really y squared squared. 2 times 2 makes 4. Powers to powers, you multiply. Okay? Are we okay with what I have written there? Okay, so that means I go 4, I make my 2 parentheses. So we're splitting up the x squareds because I have 2 x squareds. So this is going to be x squared and x squared. And x squared really make x to the 4th, right? So on our previous problems, I only had x squared, so I separate them, which makes my x squared. These x squared separate, which go back to make x to the 4th. Do we all agree with that? So that means I'm going to have 1 plus and 1 minus, and then what's going to be at the end? Y squareds. Okay, so this is good, but we always want to check if we can factor further. We have 2 terms. This is a plus, which means it's not a difference. But what is this? This is a difference. Are these both squares? Yes. So I'm going to rewrite what I cannot factor. I cannot do anything with the 4. I just write that down. I can't factor x squared plus y squared because that is not a difference of squares. But this right here is a difference of squares. So we make our parentheses. And then what do I do with my x's? We separate them and we get an x. I have 1 minus, 1 plus, and then what goes at the end? Y's. Difference, okay, difference means subtraction. So this is your subtraction slash difference. and then both terms have to be squared. So it's when you have two terms that are both squares and a minus in between. Okay? All right, example 8. I'm going to give you guys about 30 seconds. I think you guys can do this one on your own. I'm not handing out candy because I think everybody will get it done at like the same time.
Do we still have to raise our hands?
I should have you guys have your whiteboards out, but I don't. No, just, you're good.
Oh, that's all.
In a minute, yes. But just wait until we're done. No, it's okay. Okay, so I have popsicle sticks that I'm going to start using in this classroom, which have each of your beautiful names on them. So when I call your name, I want you to tell me the first step, please. Okay, so the first step, when I call your name, you're going to tell me what is the first thing that I'm going to do on this problem. So Kenny, what is the first thing I'm going to do on this problem? Very good. Is there a GCF, Kenny? Yes. Okay. So what is that? 3. So we take our 3 out, and I'm going to divide each of these by 3, and I get x squared minus 25. Okay. Next step. Okay, so I'm going to pull a popsicle stick, and I need you to tell me what I'm going to do now in this problem. Jenica. So now that we took out the 3, what do I check for when I have two terms? Exactly. Is it a difference? Yes. Okay, we know that x is a squared. Can 25 be written as a squared? Okay, good. And 25 as a square is what? Perfect. Okay, so next popsicle stick, I want you to tell me how I end up factoring my difference of squares. So you're going to need to tell me what I do for my difference of squares. Lorenzo. Perfect. The 3 and then an x plus 5 and an x minus 5 in the parentheses. Because we split up our x's, we split up our 5's. One has a plus, one has a minus. Then we check. Can any of this be factored further? No. So this is my answer. Any questions?